Okay, today we'll continue our discussion about the active power control. So we have discussed the previous class. We have discussed about the how you want to calculate the generator's contribution to the load and for the parallel generation. Okay, so today we look at the tie line model. So basically, the tie line between two generators feeding the common load can be expressed as this equation. Okay, delta P tie equals to T over S delta omega over minus delta omega 2. Delta omega 1 minus delta omega 2, where T is defined as the tie line stiffness coefficient and normally can be expressed as 377 over X tie, X your impedance. So this is the block diagram of interconnected areas. So let's say we have two areas. Okay, the power flow is from area 1 to area 2, so we have two areas. One indication indicates the area 1, 2 indicate the area 2. Okay, so I think the block diagram have been discussed in the video last time. So for those who are not familiar with the block diagram, you may refer to the video that we have discussed previously. So basically, this is our governor, prime mover, and then the output is the data Pmax. This one is the load, data PL1, meaning the load changing at the area 1. So we have plus in the max and then minus for the load. And then we have this one is what? 1 over ms plus b is what? We have discussed this thing. It's rotating mass and load. Okay. And then we have the feedback here. So this is the example of the last discussion: governor, prime mover, rotating mass load model. Governor, prime mover, and rotating mass. So this one, when we have two area, so it is connected over here. So plus minus indicate that the power flows from the area 1 to area 2, meaning that the power flow is here. Okay, so plus minus, and then we have this one is what we call the tie line stiffness, T over S, where here we have the delta P tie. As you can see, the block diagram is quite similar for area 1 to area 2. Okay, so basically we can derive these figures. So as we can see here, we look at let's say we have the data, the load change in area 1. Okay, this one, load change in area 1. So we know that our data Pmax is equals to minus delta omega over R1 and delta Pmax 2, Pmax 1, Pmax 1 and Pmax 2 is equals to delta omega over R2. So from here we can see, we can derive your delta P time minus delta PL. This one is at here. Delta omega 1 over R1 plus D1 here. Delta P tie minus delta PL1. This one is analyzing from the where? This one is area 1. Okay, you find here delta minus delta P tie. So this one is P tie. So minus delta P tie is here. Minus delta P tie. Because your delta P tie is forward to the left hand side, but now we want to find here So data Pi is minus data Pi minus data PL. Data PL1 here is equals to data omega 1 over R1 plus D1 here. Data omega here is what? Data omega 1 over R1. This one you just, I hope you can remember back when you learn about the control system, when you have the block diagram, here is you just times, right? So data omega 1 and then 1 over R1 plus D1. So 1 over R1 plus this one. Okay. So this one is H here. So this one is that minus data Pi minus data PL here is equals to data omega over 1 over R1 plus D1. And then also we can see for the area number 2, data Pi number 2 here, it is data omega 1 over R2 plus D2. So, and then you can make rearrange this equation. So you can eliminate your dpi, right? So you bring all this thing here and then this one also. So you put this equation into this equation. So and then you make a rearrangement. So and then you can get your data omega as the title equals to data PL1 divided by 1 over R1 plus 1 over R2 plus D1 plus D2. So you need to rearrange. Okay, and then once we get this value, we can put back into this equation. So you can get your change in the tie line flow is equals to data PL1 1 over R2 plus D2 divided by 1 over R1 plus 1 over R2 plus D1 plus D2. Okay, so this is example change in tie flow. So data Pi here. So let's take a look at the example. So you are given two areas connected by tie line with the characteristic given below. So a load change of 100 megawatts, or we call it 0.2 per unit, occurs in area 1. Okay. Load change, meaning that data PL1 is 100 megawatts, occurs in area 1. What is the new steady state frequency and what is the change in the tie flow? Assume both areas nominal frequency 50 Hz to begin. So we have area 1 and area 2, where your R equals to 0.01 per unit, R2 0.02, D is 0.8 per unit, D2 is 0.1 per unit, and then both have a similar base, 500. So 100 divided by 500 is 0.2 per unit. So first we need to find our data omega. Okay, you need to find the steady state frequency. This one is data omega. And also you need to find the change in tie flow. So we need the data Pi. So the data omega is equals to this equation, data PL1 divided by 1 over R1 plus 1 over R2 plus D1 plus D2. So this one is your data PL is 100 megawatts, right? So 100 megawatt divided by 500 megawatts, you got 0.2 per unit. So the value in per unit. Okay. And 1 over 0.01 plus 1 over 0.02 plus 0.8 plus 1, you get minus 0.0013172 per unit. So this one is the changing of the frequency. So to find the new steady state frequency when the load change happen at data at the area 1, is you need to find, because this one 50 minus, because this is negative, 0.00132. So okay, times 50, you get 49.934 hertz. So meaning that when they happen load change 100 megawatt in this in the area 1, your new steady state frequency is dropped from 50 Hz to 49.934 Hz. Next, you need to find the change in tide flow. Kalau awak tak dapat masuk lagi, masuk balik lah, masuk lagi, cuba lagi. Okay, kadang-kadang saya kena buka kat sini, so that's why you kena masuk awal. Okay, so we continue, and then you need to find the change in the tide flow. Delta P tide is delta omega 1 over R2 plus D2. Okay, you can use this equation. Okay, because we have all the information, so you can find directly your delta P tide. Gambar tak ni, you kena on ni. You need to on your camera first because you capture only 32 names here, but we have 50. For those who don't have your name here, please please on your camera for a moment. Or you may raise hand or do something or give comments. Okay. Okay, we continue. So we know already our delta omega. So we know our R2, we know our D. So you can find your delta P tide is 0.067 2 per unit, and then you need to times 500 because it is your base. So you get negative 33.6 megawatts change in the tie line. Okay, that's the answer. Okay, let's find example number 2. Find the change in the prime mover power and the error in total load change from example 1. So we want to find the change in prime mover. So delta Pmax equals to minus delta omega over R1. So we know already our delta omega. So this value divided by this value, you get this value, and then 2 times 500, you got 65.876. And delta Pmax 2 is delta omega over R2, get 32.938. So delta Pmax total, when you sum, you get 90. This one, sum this one, you get 98.814 megawatts. So what happened here is there is a slightly error in the total load change. Instead of 100 megawatts, in the prime mover, you get 98.1814 megawatts. So the error is 1.186 megawatts. Okay, the load change is 100, right, just now. But what happened in the prime mover is only obtained 98.814. So there is error here. Error 1.186 megawatts. So this is what we do, what happened in the step change. This is example when you have the delta PL, the load change, the frequency error here is when you plot, it is the response with the no governor action. So we just apply these things. Okay, so that's why when we apply the with governor action, meaning that you have your feedback here. Okay, so you get the less frequency error. If no group or no feedback of R1 and R2, okay, it's no feedback here, you get the error is quite bigger. Error. So when we have the governor action, you minimize the error. Okay. Okay, for those one, your name, please check again. Your name is not here. You need to do something, whether you raise your hand or you open up your camera for a moment. It's not capture, I don't know why. $35, so manage. No. In 35 duration. Okay, never mind. We'll proceed. So basically, this I think this one I'll skip. The notes will be skipped. So let's take a look at the example at the books here. I don't know why you cannot capture. It's supposed to be auto capture. Okay, never mind. We look at the other example. So basically, we have finished the topic anti-tie line control. So the additional supplementary control and so on and so forth, I will skip. So this one will not cover in this topic. So, but for those who are interested to go for the power system control, real power control in details, you can go or you can do your PSM with the respected lecturers who are expert in the AGC and so on and so forth, like Dr. Abu and myself. Okay, let's take a look at example. Example of okay, let's look at this example. Okay, two power system A and B are interconnected by tie line. Let's save these things. How to? I think this one have in here. Yeah. If you want to learn about details in the active and power and frequency control, you can find this book. This one is only chapter. You can find this book. I think this one is Kundur. Okay, you can find it online, or you can find WD and this book. Electrical power system solution. This one is solution. Electrical power system WD. Here, 5th edition. Okay, you can find it online. This is the 5th edition. My module mostly referring to these two books. So let's take a look at this example just now, right? Basically, this book contain of a lot of topics that cover, I think, at least three courses. So you have basic concept, component of power system. This one is PSOC, these two. And then load flow is PSA. Fault analysis is PSA. System stability, I think, is not covered. I don't know whether you learn about substation, but there's some protection here. Okay, I think this one's protection. So at least three courses covered by this book. It's a very good book. So my book is mainly referring to these two books. Okay, let's take a look at the example just now. Is chapter 4. Okay. Let's take a look at this one. Sign, this one is sign, close. Okay, never mind. We'll take a look at this example. Two power system A and B interconnected by tie line and have power frequency constant Ka and Kb megawatt per hertz. Okay, an increased load if 500 megawatts on system A causes the power transfer 300 megawatts from B to A. When the tie line is open, the frequency system A is 49 hertz and the system B 50 hertz. Determine the value of Ka and Kb deriving any formula used. So basically, what we have in the notes here, you need to refer to the question when the question is given like that. So basically you need to understand what is the question is what you want to solve. So let's say here you have two power system A and B interconnected by the tie line. I think this one is this example. I think have I shown this one? Not yet, right? So it's like this example. So you have system A and system B. So I put here in the Jamboard. So you have this one with system A and we have a system B. It's connected with the tie line. This one is called tie line. Just like say previously that system A you have a coefficients. We call it Ka, and system B we have Kb. Okay. For this example, load change in system B. Okay. So when you have the load change in system B, that is a power flow from A to B, okay, and delta PT is positive when the power flow from A to B. And then the change is required frequency system B due to the extra load in delta P. So you can get this equation by using this equation. The negative sign indicate the fall in frequency. The drop in frequency A to the extra load P is using this equation. Okay, so similar with the example here. For system A, we have two power system A and B interconnected by tie line and have power frequency constant Ka and Kb in terms of megawatts per hertz. And then you have Ka and Kb here. You have Ka and Kb. So one is your tie line. So increase load megawatt, 500 megawatt on system A, cause power transfer 300. Okay, so when the load change, you have delta P here, the power is transferred from B to A. Okay, the power transfer from B to A, you have the delta P here is 500 megawatts. Okay, so the change, you have 500 megawatts. Increase in load 500 megawatt on system A cause the power transfer of 300 megawatts. So meaning that here is there is power transfer 300 megawatts from B to A. When we have the data, we have the load change in the area A. So when the tie line is open, the tie line can be open. When the tie line is open, the frequency system A is 49 hertz. Okay, when the tie line is open, your frequency is become 49 hertz. And system B is 50 hertz. Okay, this one is FA, and then this is FB is 50 hertz. So determine the value of Ka, Kb, and you can derive any formula used. So that's why you can use here. So what happened if system A, you have the load change is 500, and then you receive 300 from B, that's why you get negative. Okay, so 500 minus 300 divided by Ka, you can get your delta F or delta omega in terms of the frequency change. So that's why you can get the value 200 divided by Ka. Okay, the load change 500, and then you receive 300 from B to A. That's why you divide negative. That's why you need to deduct. And then for system B, since the system, the load or the power is going out from the area is positive. Okay, remember when you learn about the power transfer, when you receive is negative and you go out is positive. Okay, so that's why you get the for system B 300 divided by Kb equals to delta F. The delta F is similar with both frequency, both system, and then you can get here is, since these two is equal, 200 by Ka, 200 over Ka equals to 300. Okay, 200 over Ka, because it's a delta frequency, is similar, equals to 300 Kb. So you can use, you can solve these things. So basically you can get Kb equals to, or Ka equals to, Ka 300, can get here what? Kb equals to 1.5 Ka. Kb equals to 300 by 200 Ka, right? So you just bring here. So that's why you get Kb equals to 300 by 200 is 1.5. KA. Okay. Next. Next, we want to find our FA. We know our FA already. Our FA is 49. Our FB is 50. So basically our FA is equals to F minus 300 divided by KA, and then FB F plus 300 divided by KB. Why like this? Because is wait you can refer here. Okay, we consider both system operated at the common frequency, and then the connecting links is now open, A is relieved, and assume the frequency FA and delta B PT more loads. So when you have more loads, so that's why you F plus FPT divided by KA. This one is your equations when you have more loads, and assume FB, and then this one is must be negative. So similar from here. So your FB, this one you receive, right? So F minus 300 by KA, and FB, because the power is transferred from B to A, 300. So you have F plus 300 by KB divided by KB. So from these two equations, basically you can, because you have a common frequency here, so this equation, so I just write this one. Your FA equals to F minus 300 by KA, and then you have FB equals to F plus 300 plus KB. So these two equations, you can eliminate your F by minus these two equations, right? So that's why you get here. Okay, plus plus. So FB minus FA. So this one is minus, the F is cancelled. So 300 minus minus become positive. So that's why you get, because FB is 50 Hertz, F9 is 49 Hertz. You can, basically you can make like this one minus this one, also this one minus one. It's similar because we have a negative value, no problem. So that's why you get here 550 minus 59, 49 equals to 300. And then we know already our KB is 1.5 KA. You just put this value into here. So at the end of the day, you can get your KA is 500 megawatts per hertz, and KB equals to 1.5 KA equals to 750 megawatt per hertz. Okay. So this is how we want to solve this example. Okay. Any question?
Sir.
Yes.
Boleh terangkan balik kenapa FA tu dia tolak? F tolak.
Macam mana?
Kenapa yang F tu?
Ni dia tolak sebab ni tengok kat sini, dan nota saya tak ada ni dalam buku. Saya tak ni update lagi. Kalau ni kat dalam sini dia kata kalau this example is different. This example from system A to system B. Contoh ni system B to system A kan. Okay, yang ni saya akan cuba masuk dalam ni nota. Okay. So basically when you have this a system, a tie line system, two power system that connected with the tie line here. So you have when there is a load change in the B, contoh kat sini ialah B, at system B, you have load change in this area, and then suddenly the tie line is open. So what happened is negative ni, you get the negative value. Negative sign indicates the fall of frequency ya. So that's why you need to, kat sini bila load change bertambah kan, bila you load bertambah, you punya frequency change to down. Kalau contoh, kalau soalan saya buat load berkurang, so your frequency will become higher lah. So that's why negative, because your frequency is down. Mana saya contoh tadi. Okay, that's why you get this equation. Nota ni tak ada dalam nota, nanti saya akan masuk dalam nota this part, this style line. Mana tadi? Okay, so contoh ni, this example, as I said previously, this example you have load change. Okay, it's positive, maknanya load bertambah. Kalau positif 500 suddenly increase the load, that's why your frequency drop. So that's why dekat FB you minus lah, dekat FA you, dekat area A you plus. Okay, and then you can analyze. So this question basically is, firstly, the power is transferred, the load change happen at area A 500, right? Increase load. So that's why dia kena tolak sini. Kalau the load decrease, berkurangan, so you kena tambah. Your frequency become increase of the frequency. This one is increase in load. Okay, never mind. So we try to make another example later. So let's take a look at the last semester punya soalan, previous semester punya contoh soalan. This one right. Soalan test ke soalan final? Ya, soalan final. Final. Test. This one is final. Ini soalan sama kan? This is last semester punya soalan. Two power system AB, Thailand power frequency constant KB increase 500 from B to A. Ini soalan sama. When Thailand is open. Ini soalan sama lah. Ada soalan saya buat lain sikit. Soalan test. This one. Okay, let's buat ni ya. Ni sebab soalan yang open-ended. Two power system A and B interconnected by tie line, increase in load 500 megawatts on system B cause power transfer megawatt A to B. When the tie line is open, the frequency system A is 50, system B is 1949. Calculate the value of stiffness for each system. So it's basically similar lah. So you have the system FKA. Now the power transfer from A to B, right? So the increased load 500 megawatts, data P goes to 500 megawatts. In B ni let's say tak ada ni lah, so 200 dia pergi. Okay, when there is increment in the KB, there is power transfer from KA to KB is 200 megawatts. And then when Thailand is open, at this thing, mula-mula your frequency is similar, operating at the same speed. When the Thailand is open, the system B is 49. Frequency A is 50. So calculate the value of stiffness, meaning that you calculate the value of KA and KB. Okay, we just use like this expression. So this one A to B, B to A. So now for system A is for system A, what? Your data frequency equals to 200 divided by 200 divided by KA. And then for system B, it's what? 500 minus 200 divided by KB equals to delta F. Okay. So soalan dia bila dia open, your frequency now is 50 Hz for KA, for KB is 49. So your FA now if F plus 200, right? So your F plus 200 over K plus, because it's now the situation now is different, is terbalik. So F might plus 200 divided by KA, FB, F minus 200 by KA, FB, F minus 200 per KB. So from here you can similarize kan, samakan. So 200 over KA divided by equals to 300 over KB. Okay, so you get your KB equals to 1.5 KA. KB, K. Ni 500 tolak 300. Balik ni, sama kan? Ni 500 tolak 200. Sama. Okay, so you get these two equation. Equation 1, so equation 2. So nak senang, you buat FA minus FA is 50 Hz. So 50 Hz minus 49 Hz. So F minus F 0, 200 minus 200, you got 400 lah. Equals to 400 per Hello? Dengar tak?
Boleh.
Sorry.
Boleh.
Internet sangkut tadi.
Boleh sir. Tadi putus ni.
Putus. Sorry. Internet sangkut. Recorded already, so share balik semula. That's the problem. It's not only you yang sangkut-sangkut, kat UMP pun sangkut juga. Okay, nampak lah?
Boleh.
Sorry, just now it's disconnected. So you can solve these things, kan? Boleh solve. And then you solve this one. KB is equals to 1.5 Ka. Is 1 Hertz equals to 200 1 over Ka minus become plus, right? This one plus. Plus 1 over 1.5 Ka. So you can do solution lah, you dapat berapa. Okay, that's example. Contoh soalan tahun lepas, soalan test. I'm not sure whether this question will be emerge again or not, because now we are still under discussion with the, I don't know why, tengah buat apa ni, you all punya final exam sekarang ni, issue of 20% or 40%. So sekarang ni saya tak sure ni, kalau betul 20%, if your final exam is 20%, so I will do only 2 questions for your final exam. Instead of 3 hours, is changed to 1.5 hours only. Play. Still under discussion.
Sir, nak tanya sir.
Yeah.
Final dia online ke apa sir?
Saya pun tak tahu nak cakap apa. Now case makin naik. COVID-19 case in Pahang, I think on Monday is 33 cases, and then yesterday is 55 cases. Kat Pekan pun ada case, dekat Kuantan pun ada case dekat Taman Tas, case apa ni, orang yang main Zumba tu. UMP pun saya tak sure, PY ada lah, person under investigation ada dekat komputer kot. So I'm not sure. The worst case is online. So if online, what I can do is similar with your test lah. Contoh soalan ni, ini contoh soalan. This one is example for last, I think this one is test, right? The test 2. So macam ni lah. So saya kena buat soalan tu to make sure that you get a different answer like the test 1. So that is what happened. I hope that you can, I don't know, because last semester I think face to face, right? PSOC face to face. Your senior balik for final, and then case naik tiba-tiba, and then change back to dia ada dua tiga batch lah. So last semester I think I have about 30 something student. Seorang dia yang datang untuk second batch. So yang itu buat online. Hopefully, I don't know. Tak tahu nak hope apa. You all face to face ke online?
Face to face.
Face to face lah. Bukan online boleh tiru.
Open book susah lagi lah.
Ya ke? So itulah yang berlaku. Hopefully kita boleh ni lah, kita mesti menang lah this COVID macam mana, by hook or by crook. You all at least dah masuk UMP dah. Can you imagine tahun 1? Tak masuk lagi. Pergi kelas pun tak jumpa orang lagi. Tak jumpa lecturer, tak jumpa kawan lagi. So kalau COVID ni extend, kalau diploma is what 2 years and a half kan? 2 tahun lebih kan? Kalau COVID ni 2 tahun, dia tak masuk universiti langsung. Tu yang berlaku lah. So hopefully the COVID tahun depan okey kot. Tapi memang supposed to be 2 years lah. You all semua tahun 3, tahun 4 kan? Okay, yang tahun 3 tu ada kepada kalian untuk jumpa. Tahun 4 ni I'm not sure. For those who are fourth year, you will have PSM. So I think by hook or by crook, you need to come back lah to finish your. For those who are using yang buat simulation, boleh buat kat rumah. But for those who are yang ada hardware tu memang kena datang lah. Okay, so you all prefer online or face to face?
Face to face.
Face to face So now we have what we left is kita tengok balik schedule kita. So today I will give you project individu Okay, kalau online, if online your final exam is online, so it will become to make your final is 20% only. So the other 20% will be embedded in the individual assignment or individual project. So I just give you project 10%. If let's say you will have face-to-face final exam online, so meaning that your final exam is about half of the, instead of 3 hours will become 1.5 hours. Instead of 4 questions will become 2 questions. So the other 20% will be embedded in your project or assignment, because we have another project 10%, another assignment 5%. Maybe I increase the assignment number 2 to 10%. Okay, project to 10%, 20%. So your project become 25%. Okay. So I think we have discussed, we have finished the active power control. So like I said previously, that the rest is I will not cover, meaning if I not cover, meaning it's not will be emerged in the final exam or test, any test. It's just my notes. I just prepare it more than supposed to be lebih daripada apa yang perlu belajar lah. Okay, so today I will give you a project. Let's take a look project. Let's take a peek tengok. So this project basically is you need to solve economic dispatch problem. So dalam kelas kita belajar sampai berapa? 3 atau 4 generator only, right? So for this project you need to use MATLAB. Okay, and then you need to do some programming, because this is a individual project. So you need to do, you can discuss, but you need to submit your program as well as your report before 31st December. Cukup tak? Cukup tak masa?
Tak.
Ada berapa minggu gini? 1, 2, 3, 4 minggu lagi?
Tidak rasa.
Empat je.
Satu nak sampai bila? Satu nak sampai bila?
Study week.
Macam ni? Dia lama sangat ni. Tak boleh. 7 lah. 7 January boleh? 7 of January. Sebab saya target minggu ni dah tak ada dah kelas ni. Habis dah ni. Okay, 7 January boleh?
Oh, okey dah tu.
Boleh sir.
Okay, 7
Boleh.
January. You need to submit your report.
Boleh sir.
report as well as your program. Jangan tirulah. Kalau you tiru, saya tolak markah seadanya lah. Okay, I will send you the turn it in dah ada kan? You need to send to Kalam and turn it in lah. Your report in turn it in 7 of January. Baru dah. Okay, ada 15 generator. Yep.
Turn-in tu kena berapa persen?
Hijau lah.
Hijau, okay.
As long as hijau. Mana tadi? So ada 15 generator. So you have minimum power, maximum power. You have A, B, C. This one is alpha, beta, gamma lah. Okay, so you need to do program is 100 marks. I think it's present. And then you need to do all methods. Sebelum ni saya suruh pilih 2 method. But this semester you need to do all methods. 15 generator. Okay, and then you do discussion. The load is 2630 and then you can compare with my papers. You can compare with other papers. Okay, and then for those who want to extra marks, you can use any optimization technique available in online. So that's why for those who are doing PSM, especially doing PSM with me as well as Dr. Nurul Asma ataupun lecturer yang buat power system ni, this is a stepping stone you to learn initially about the programming of MATLAB of optimization technique. Okay, it's like to kill 2 birds with 1 stone lah. Okay, I can give you extra mark if we have learned several methods, right? So that method you need to do programming, and then for those who want the extra marks, you can use any optimization technique available in the literature. Boleh? Boleh? Kelas?
Boleh.
Boleh sir.
Okay, I think that's all for today. So later I will share this video lah. Okay, ada soalan lain?
Tak ada, sir.
Okay, kalau tak ada, so wait kita tengok balik you punya test bila. Your test is supposed to be 31st December, test 2. Okay, never mind. So next week, besok lah. Besok we try to look at the new topic, reactive power control. Okay. Ada soalan? Ada soalan? Kelas?
No.
Tak ada.
Okay, kalau tak ada, I think that's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.